Hello and welcome to Tech Fortified, where you become a tech magician. In today's tutorial, we'll be building a real-time Twitter-like newsfeed using server-sent event. You can see our application over here that we are open. We have opened three tabs, and if we go ahead and like any of these posts, these tabs are different users that have logged in or they have opened our application. So it could be you, it could be anybody. So let's go ahead and try it. Just watch the counter and see. And there will be a toast notification also notifying the user that a new post has been liked. So if I like this post, you can see these two devices have received a notification. So and the post has incremented to 7. Likewise, if I like over here, it will increment. So you can see everything is happening just like Twitter. Like when you're on Twitter, everything is in real time. So you can see the post has incremented to 9. If I go down again and like any post, this one again, or let me scroll this side too down and I like this one, you can see every side is incremented in real time and there is notification. So you can see everything is happening in real time. This is powered by server sent event. So what if I go ahead and add any new post? If I add any new post, it will as well appear in all the tabs. So let's assume this user has a new post. I say hello world, and I paste the image link, then I press the post content. Hello world, this is me. Just watch this side on the left hand side and on the right hand side. You will see the post appearing immediately. The post is added. So new post, no new incoming post, and then the post is automatically added, so you can see it. And if I should go ahead and like this post, this user will receive two notifications. See, one notification is the post being liked, and another notification is his post being liked because this post is added by this user. So you can see in this tutorial we have tackled and sending global event to all users and sending a specific event. So you can see that whenever they like this post that has been added by this user, he receives two notifications, one for the post being liked and two for his post being liked. So if I like over here, you can see he's going to receive two notifications, one down here and one down here. So likewise, if he likes, these two users will be notified immediately. So if you want to see how this application is built, please just stay till the end of this story. Before we continue, if you're new to my YouTube channel, please subscribe. It doesn't cost you a dime to subscribe to my YouTube channel. Everything is completely free. This educational content that I'm uploading here is completely free. So just do me a favor and subscribe to my YouTube channel. Thank you. Just like I said, today we'll be building a Twitter-like real-time newsfeed using server-sent event. So let's take a brief look at server-sent event. So if you are familiar with client-server communication, you will know that a client application, e.g. this mobile phone, has to make a request to the server, and the server has to check the request, process, and send back response. So that is how traditionally a web application behaves. But we live in a world where real-time communication has become a necessity. So there is almost no application that is not real-time unless it doesn't have any feature like notification. So you can see a situation where, or a process where the client has to request data from the server has to process and send back response is known as polling. So and this is the method, or this is the way that we have been using our normal day-to-day application. We have different ways of real-time data communication. We have WebSocket, we have socket.io, we have server-sent event. Now, what is the difference between WebSocket, socket.io, and server-sent event? The difference is that WebSocket and socket.io is one bidirectional. That you say the server the client can be able to send data to the server and the server can be able to send data to the client as well. There are scenarios where you need to push data only from the server side down to the client application. Things like maybe a notification system, or you want to notify a user's friends that a user has come online. You can see that those users don't need to make requests to the server to determine if their friend is online, but the server should be able to send down the data down to the client to their mobile devices whenever their friend comes online. So that is where server-side event thrives. So, but you could achieve the same result with WebSocket and Socket.io, but this will rather create an overhead for you because you are not making use of the client doesn't necessarily need to send data to the server. So you don't need to implement this. You can instead go with server-side event. So let's check in details what is server-side event. So what is server-side event? Server-side event is an HTTP standard that enables a client application to automatically receive update or event streams from the server once an initial connection has been established. So you can see that when we have a server and we have a client application and we want only the server to be pushing down notification or data stream down to the client, all the client needs to do is to make initial connection to the server, and that's all using this server sent event, and the server will handle the rest. So whenever there is such an update, the server will push it down to the client, and the client can listen to it through what is known as event. So you can see that with server sent event, we don't need to build another protocol. It works with the normal HTTP protocol and most modern browsers support it. And it is unidirectional by nature. That you say only server can push update to the client once an initial connection has been established. And another thing is server-side event is commonly used to send automatic update, things like stock prices, cryptocurrency updates, newsfeed notifications, and we're going to see that. Using SSE in a JavaScript application is as simple as calling the event source. So this is how you instantiate it. Just call the event source and pass the URL that the server URL that you want to connect to. So there are two options of passing. You can either pass the URL only, or you can pass the URL with an option with credentials through. So when you pass it with this with credentials through, you are telling to allow cookies or auth headers. For instance, you want to authenticate who is accessing the resource, you have to do this. So and then whenever you instantiate this event source, it has an event, the object, you can be able to listen to event, default event from the object, and the default events are open when the connection has been established, and message when the server send down a message from the server down to the browser, and error event whenever there is an error. You can also have an object properties on this event and object. So the ready state contains three states: zero, which represents it is trying to connect, which is connecting; open, when the connection has been established between the client and the server; and closed, when the connection is closed either from the server or from the browser. And URL, a property also known as URL, if you want to know the URL that the server sent event is calling. And then with credentials to check if it is either true or false. By default it is false, to see if your connection was established with credentials. And you can call this closed method uh, on the SSE object to close the connection. Another thing is how to use SSE on the server. So in order to use SSE on the server, the data sent to this by the server to the browser must be UTF-8 encoded text with the following HTTP header. So the content type must be text like event stream, cache control, no cache, connection, keep alive. And whenever you are sending the data, the information sent each time consists of several messages, and each message is separated by what? /n/n. Each message is composed of several lines of code internally. Each line should be written as follows. So each message that you are sending from the server sent event, that is from the server using server sent event down to the browser, retry. But the compulsory one is the one that is required over here is the data. You can specify the event if you want to change it to a custom event. Remember I told you by default the default events are what? Error, message, and open. But if you don't specify any event, the message is the on message listener is going to receive the data. So you can specify the ID if you want the server, maybe the browser disconnects. If you want the server to continue from where the last message is sent, and the retry How many seconds do you want the server to retry or the browser to reconnect whenever it disconnects or there is an error? So these are the properties in the feed that are involved in the feed that you must pass. So you can see that whenever a device establishes a connection to the server, different devices establish connection to the server at once. It is done whenever the update is available on the server will push it down to the devices. This is how SSE works. And one good thing about SSE is that if your browser disconnects, whenever it comes back online, the browser will try to reconnect automatically. So that is one thing about and server sent event, and the data will start sending immediately from the server. So examples of server sent event include newsfeed. When you are building a newsfeed like Twitter, Facebook, friends online status. When your friends comes online and you want to be notified or you want to notify a user's friends, cryptocurrency update. You can see that cryptocurrency update, the prices keeps changing. So if you want to make use of this technology, it will be well fitted in this. Notifications. For instance, something happens within your application, you want to notify a particular user or all users that something has happened. Comments and like reactions. So you can be able to send comments, like reactions in real time. Stock prices. So you know that when stock prices changes, and sports results. When you want to send down sports result, maybe as everything is happening in real time. So in this tutorial, what are you going to learn? You are going to learn how to implement SSE in a React.js and Node.js application. You are going to learn how to push data to all users, to push data to a single user. You are going to learn how to implement a like button. You are going to learn API, how to build a basic API. You are going to learn React hooks, useState, useContext, and useReducer. And at the end, we are going to host this application. So what are the libraries that we'll be using on the client side? We are going to use React, Axios, NDB React UI Kit, JavaScript Event Source, React Toastify for the notification pop-up, and Nano ID for generating IDs. So the libraries and API that we'll be using on the server include Express, Compression, Helmet, Express SSE, NodeMon, Cause.env, Nano ID, MongoDB, which is and we'll be using a Mongoose library. So stay tuned for this tutorial. Back here in our VS Code, I've created a directory known as Super React SSE, and inside the directory I've created two directories, the client and the server. So inside our client I've created a React boilerplate. So by the way, if you are not familiar with React, this is an advanced course. So I guess anyone taking this course is already familiar with React. If you are not familiar with React, just open your CMD and navigate to client directory and run npx create React app and then the name of your app, and it will be created in this client directory and then in our servers. So let's go ahead and start our basic Express server by navigating to this directory. Alright, so here in my CMD, I'm already in server, so I'm going to npm init. It's asking me the package name, so I'll leave it as server. I'll leave the version. I'll leave the git keywords. Let me just say SSE Node.js MIT license and yes. Then let me install the necessary packages in npm install. I need Express. I need Express SSE SSE. I need compression. I need helmet, cars, mongoose we use as our MongoDB database. I need nano ID. I need .env. Hit enter. Let's wait for it to install. Okay, you can see that our packages are finished install. We will install another package known as NodeMon. So npm install -sef -dev NodeMon. It's a dev dependency. Let's wait for it to install. Alright, Back here in our VS Code, if we expand this server directory, you can see that all the packages we have installed are showing over here in package.json file, and you can see the dependencies and the dev dependency. So let's go ahead and configure our script so that it can be able to start our Node.js app. So first of all, we add a key known as start. So start, and whenever we run this start script, it should node index.js start our main file. We'll be creating that file in a while, and then we can have maybe dev start or node mode over here as another script. Can be any name, so call it node mode over here, index.js. So after we are done with this, let's go ahead and create a file known as index.js. So the index.js is the one. This index.js file is the one we are referencing in our script, in our start script and in our node mode script. So over here, if we just do console.log, maybe hello world, let's save everything. Then we'll navigate to our CMD and run this script and see. Alright, so just run node mode and see. Let's see. Alright, you can see our server has started over here, and you can see the hello world that we had in our file over here, which is displaying in our CMD. So now let's set up our basic server. So before we set up our basic server, let's create some files over here, some files and directories. So first of all, create .env. Here we'll be dropping our environment variables, and still within inside this, create another directory known as route. This one we call our route. Create another directory known as controller. So I will go ahead and create these controllers. I will go ahead and create these directories. Alright, we have created some directories: config, controllers, db. You can see all of them are empty at the moment. db, models, route, services, SSE. So inside our .env, we will be dropping our environment variables. Let's go ahead and add these variables over here. We add the port, we have added port 5000, local app where your client app will be hosted. In this case, our client app will be hosted on port 3000, and then the remote URL where you'll be hosting this, and then our MongoDB URL. So and the one that we are listening on locally. So you can see it over here. So these are the variables that we'll be adding. So inside our config, we go ahead and import our variables. So just create an index.js file over here. After we have created this index.js, let's go ahead and add these variables, this configuration. So you can see over here, we are importing this process in order to import these variables, environment variables in our config file. We need to call process.env. So you can see we have port over here, local. Alright, next step now is to set up our database. So let's set up our database over here by creating index.js. Now within our index.js, we go ahead and import mongoose and then set up our database. Alright, within this our index.js, we have imported mongoose from mongoose. We have imported from config. We imported and config because inside our config have our MongoDB URL. So if you open this config, you will see it. Here is our MongoDB key. So if it is in production, it will pick the production URL, and if it is in development, it will pick the local URL. So now we have imported and destructured this MongoDB from config, and then we created an async function, and then we await mongoose.connect. So and if it's connected, we say MongoDB connected, and if it is error, we just log the error. So let's go ahead in our index.js and create our startup express file because you can see it is empty. Alright, so back in our index.js file, we have required .env. So this .env package will enable us to read these environment variables. So you can see we have environment variables over here, but before we can be able to make use of it in our application, we must install the .env package. So if we don't install the .env package, all this process.env that we are calling over here, including the variable name, will not work. In order for the process.env the variable name to work, we must require this package. It should be the number one package in your Node.js app. We have required and called the config method on it. We have required HTTP express CORS. CORS is used to allow our client application to connect, to communicate with our server application. It stands for cross origin resource sharing. We require element so that we can set up our headers properly. We require compression so that before we send out our response, we compress it. And then this config is a config we have created over here so that we can be able to get the port and the origin that our course will be listening on. Then we require MongoDB connection from the database. You can see we created the database file over here. So now over here we want to configure our server. So we destructure port and origin from config. If you can check it out over here, see port and origin over here. So and then we want to pass this course as a middleware. So one thing with course is the course takes the origin and then you pass this optional credentials through. Client application, do you want to connect to do you want to allow you to connect to our server to communicate with our server? So here in our env we say our application is hosted on port 3000. So and when we go online it should be hosted on sse.tech45.com. So either when our application is in production it will pick this one, and if it is locally it will pick this one. So this way we'll be starting our react.js application. So now that is the origin and the credential. When we want to send allow our client application to communicate with server side application and allow cookies to be sent or auth headers, we put this credentials true. So the next one is helmet. We use this helmet middleware so that it can be able to set up our headers, our request headers properly, or our response headers properly. We use compression before sending it out. We use express.json so that we can be able to use Json. And we use an URL encode extended first as another middleware. And we want to start our DB connection, our MongoDB connection. Then this connection that were created under DB over here, this is the one. So since we exported it as a default, you can call it any name of our choice. You can see I call it an MongoDB connection, and I've imported it as MongoDB from DB file or DB directory. So and then I says const server is equals to http.create server, pass the express app, see it over here, the express app, and then a console.log my server is running. So let's save everything and test it out and see. Alright, so if you set up everything properly, you can see that our server is up and running on port 5000 and our MongoDB is connected successfully. So right now, the next thing that we need to do is, let's close these files first. The next thing we need to do is we need to create our database schema. So go inside models and create a file known as post model. So inside this post model, we are going to create our schema and our post model and I export it. So you can see we require mongoose from mongoose, and then we create a post schema as with mongoose. So we say new mongoose.schema. Then we want the post to have user ID, title, content, photo, URL, likers. So and we say the type, this one should have type of string and required, but this one we say it should be the liker is going to be an array. So if different users like the post, we push them inside this array, and by default the array should be empty. Then timestamps, we want it to show the time, the update and the created time, and then we say const model is equals to mongoose.model. Then we pass it a name, and then the post schema, this one that we created, and then we export our post model. The next step over here, we want to make use of this post model in our services to create and post and to read post. So all we have to do is to create another file over here known as post.services. Just call it post.services.js. We have imported post model from this model that we have just created, this model. We want to make use of it in our services because the service is the one that will be communicating with the database. So first of all, we create a function get post service. This function is responsible for getting all our post so that we can send it to the client. So we say conservate post dot find. So we want to get the post length to determine if post is empty so that we can show the status code accordingly. So get the length, const length. We say to get a message, if length is equal to 0, we say not found, else we say success. So, and if length again is equal to 0, we say error true, and else we say false. The status code, we say if length is equal to 0, status code should be 404, not found. So, and then else it should be 200, and then we go ahead and return data. Then we return data as the post that we fetch from the database, this one, error, this one, message, like that as an object. Else if an error occur in this try and catch, we go ahead again and return data empty, array, error, true, message, sorry, an error occurred, status code 500. We created another function for creating a post. So we call it create post service. When one wants to create a post, we first of all await post.create, then we pass the post object that we'll be sending, we'll be getting it from controller. And then we have a structure of the data that we are returning as well. If everything happens successfully, we know that success. But if an error occurs, we return the error. Alright, so another function is const update post reaction, and we want the function to take post ID and user ID. So when somebody likes a post, which post and who likes the post. So this post is a post that the person must have liked, and this is a person's user ID. Then we call post model, they'll find by ID and update. So we find the post ID by ID, and then we need to call this operator known as push, and then we need to specify the key that we want to push. Remember, in our post model here we define our likers as an array of string. So we want a situation where whenever someone likes a post, we push the person's ID to likers. So over here we specify the key that we want it to push to. So push this ID to likers and return new true, so that whenever it updates, it will return the newly updated version on that particular post. And then we go ahead and return it data, error, false, message, success, like that. At the end of the day, another one is we want to create a notification and object. For instance, now a user's post is liked, we want to notify him that his post has been liked. So we created this, there will be an object. When somebody likes a post, we'll be calling this function to create that notification object. So we call this ID, the unique ID of this notification should be nano ID, the owner of the post should be the author. We'll be sending it, which we will receive it as a parameter over here. And then we have meta describing the post, maybe post ID. Then below over here we went ahead and export our get post service, create post service, update post service, create notification service. All these are the functions that we have created up here. So these are the functions. So once you have done this, so the next step now is to create our SSE. Our SSE is server sent event. This is the file that will be responsible for sending out our SSE event. Remember, we are creating a real-time application where whenever there is a new post update or reaction, we will notify all other users, every user that is using our application. So over here, let's go ahead and create index.js. So over here, we configure our SSE so that it will be globally available to use anywhere. So in order to do that, we we installed a package known as Express SSE. It's a wrapper built around the Node.js application for using SSE on Node.js. So in order to use this, we since this is a class, we need to instantiate it. We say const SSE is equal to new SSE, and then by default it requires you that you should send a default data so that it can be answerable on the client side through our message event. So now we just pass a dummy data. You can pass it anything over here. So and then we exported this to be used globally. So the next step now, we need to create our post controller, because you can see we have created post services over here. There's also these functions, but where can we use this create post, get post services inside controller? So inside our controller, let's create a file known as post.controllers.js. We require all our functions from post services. All these functions get post service update in our post controller. Then we also require this our SSE that we just created, this one that we have configured globally, so that we can be able to dispatch event or to push down data to the client. So over here we call get post controller. So whenever a user makes a request, this is the function that will handle getting of the post. So we call const result is equal to await what get post. So this is going to be a normal API that will be called on the client. So whenever it is called, next we go to route so that we see where this function get post controller is used. So whenever it is called, we now call our get post service, which is the one communicating with our database. You can see it up here. We say it should get all the post and return this object that will contain data, error message, and status code. So we call it. So we call this function get post service from services, and the result, you can see when we hover over this result, it's going to return data, error message, status code. So now we want, irrespective of the status code, we want to go ahead and send the status result or status code. So it can be 404, which is post not found, and then we JSON the result. So the next function over here, we created a function for creating our post controller, that is creating our post. So we call it create post controller, then we call our post service, create post service. Over here is going to get the request.body, which post the user wants to create. So inside it, inside and create this one now we called, and then we pass the body of the post to be created. So you can see over here we have in our services is the one communicating with our database. So you can see we have create post service where it is going to create this post and return this object. So it's going to return, then we send the response. But before we now push broadcast this data using SSE server sent event to all other users who are connected to our application, we want to check if the result that is returned from creating this post is not an error. So we say if not result or error, because remember we are returning error. So if error occurred over here, we return error true, and if no error occurred, we return false. So this condition over here, we check if it is not an error. If it is not an error, we go ahead and send our SSE. So this express SSE has handled all the sending of all the boiler code for sending for using a server sent event on Express for us behind the scene, and it has exposed a method known as send. So and the send now takes the data and the event and sometimes optional ID, if any. So over here, we are sending the first one, we are sending the post that the user must have created. So you can see this post is going to be an object. So we extracted it from this data. Over here we at array at index 0 return the post, that is the data you serve as data, and then we send an event by name post, so that we go ahead on the client side, listen to this event of post and get the post to all users that are connected to application. So this is where we use this express SSE to send data, to broadcast data to all users who are connected to our client application. Next, what if a user likes a post? We want to notify all users. we created this update post reaction controller. So over here, whenever a user likes a post, we are going to get the post ID and the user ID. So the post ID will come from params and the user ID will come from the body. So we call update post reaction, we pass the post ID and the user ID. So if you check under our services over here, update post reaction is getting the post ID and is getting the user ID. Then we go ahead and update it in the database so that we increment the number of the number of likers. So we now want to check if there is no error occurred. So remember, whenever there is a post update, like someone has liked a post, there are two events that we need to broadcast. We need to broadcast an event that will notify all the users who are connected to our application that the post has liked. And we also want to notify that user, that the owner of that post, that his post has been liked. Over here, we are checking if no error occurred after someone has liked a post. There are two things that are going to happen over here. First of all, we need to broadcast globally to all users that a post has been liked so that the post counter, like counter will be incremented. And also we want to send a notification to the user that to the owner of the post that his post has been liked. So this is where the logic of sending post to a particular user happens. So many people find it difficult to broadcast an SSE event to a particular user, since in SSE we cannot send data from the client. So I devised a means, a logic, a technique that we can do so that whenever there is we want to send a notification, since the author ID is unique to any user that is connected to our application, we now append the event key as the author ID. So I say notification underscore the author ID. So we can only have one particular author ID, which will be that particular author. So this event will go specifically to that particular user's device. Only that user will be able to listen to this. But this one that we are broadcasting here globally, anyone that is connected to our application will be able to see. So this is why the logic of handling different sending out different SSE event to unique users happen. So many people find it difficult whenever they are using it. But if you follow this tutorial now, you are able to understand. So whenever you want to send a specific event to a particular user, append the user's ID. Whenever you want to send a specific SSE event to a particular user, no matter this key can be any, you can put it, and maybe you want to send a specific message, you can change the notification over here to message underscore ID, and on the client application you listen to this message underscore author ID, because this is going to be what specific, but over here is notification underscore author ID that we want to listen on our client. So this will be specific to a particular user. It will be that particular user that will be able to listen to it. But before we send this particular event to notify the user that his post has been liked, this one, remember, two events are being sent here: the post reaction, which will be general, and the notification underscore author ID, which will be specific to that user. So but before we send it, we want to check if post dot user ID is not equal to the user ID. We don't want a situation where when I like my own post, I will still get a notification sent to me that I've liked my own post. I want a global notification. The global notification, everyone is going to see it irrespective of the person that has liked the post. Whether it's my post, I'm going to see it. But there is another special notification that I want to notify the post author if he is not the one that has liked the post, that his post has been liked. So in order to avoid that, I set a condition over here and say if post.user ID is not equal to the present user ID that has liked this post that we are getting from the request body, then you should go ahead, create this notification by calling this notification function over here in our postal service. Here is a notification function. It will create this notification payload and return it. And then we go ahead, grab it and send it to the post author. So over here, and then we export all these functions so that we can go ahead and use this as our handlers under and post route. So under our route, we're supposed to have two files over here. So we are going to have post dot route. This is where we specify our route.js, and another route that we'll be having is SSE.route, because we need to create a route that that our SSE, our server sent event, will be listening on. That is a route that we are going to specify in our client application so that it can be able to be getting live stream from our server. So inside our post.route, we need to specify the route first. So inside our post.route, we we have required all our post controllers function over here. You can see we exported these three functions, so it's the one that we're making use of in our post route. So and then we require express again, and then we use this express to create a router, because this express has a static method known as, or it has a static method that you can be able to access known as router. So we call express dot what router. So and then we say router dot get whenever someone who makes request to our server with the endpoint of slash post, we call this post controller get post controller. Remember, in our post dot controller over here, we created a post controller that is responsible for calling our post service to get our post, and it will just answer. So this post controller is the handler that will handling this request whenever they make request to this endpoint. And then what if they post, somebody wants to create a post, we call create post handler, so that it can be able to get the post. And you can see over here we pass it what request and response, so that we get the post and send it to post service. Post service we call database and set our post in the database. Then we create whenever somebody wants to patch, that is whenever there is a like reaction, we call this router.patch, and then we call update um, reaction controller. At the end of the day, we now export our router. So this our router now, we go ahead and use it in our index.js. But before then, let's set our SSE dot route, because this is the one that we'll be making use of. This is the route that we created to listen to live stream. So when we create this route, we now call our client application to listen on this route, so that whenever in our post controller over here, when an event is broadcasted like this post event over here using SSE, our server sent event, any application that is connected in this our SSE route can be able to listen to that, get that event and display in our client application. So let's configure this SSE dot. So just like post.route, in our SSE.route we require express and we require what SSE. So remember, we configured our SSE over here, we exported it globally so that we can be able to go ahead and use it in any file that we want. So when we export it, but in order for you to use this library, this express-sse library, you need to call a function known as init on that route that you want to listen on event. So over here in this, after we have created our router and say whenever a client application is connected to this stream route, we now call this our global SSE that we have configured, the init property. So this init, we go ahead and init this, start listening on this route. So whenever there is an event that is broadcasted, this our get stream will go ahead and push this event to this stream route. So any client application that is connected to this stream route will be able to receive real-time update from our application. So this is how we configure the route that our application will listen on. So and this is how we configure our global SSE so that we can go ahead and use it in any file. So over here, where are we emitting this SSE event is in our controller. You can see over here in our controller that we have imported this SSE at the top. It has exposed a method known as what? Send, so that whenever you want to emit any event that somebody that is connected on this get string should listen on, you call this what? Send. Then you pass, if you hover over it, it takes the parameter of what? Of data, event and optional ID. But we are passing the data as the post, and the event name is a custom event, so you can call it any name of our choice. We say post. And whenever there is a post update reaction, you can see again we call send. We pass data and we pass the event, custom event name. So this event, we are going to go ahead and listen on them on our client application. So and then over here, when we want to send event to specific user, I told you append what? Append append, let's put dash over here, append the author ID. So the event name now will be notification dash at author ID. So whichever author that is connected to our client application, we create this on the client side that we're listening on. So if a notification is sent specifically to that author, we will listen on this event and this notification dash authenticate it and display it to the author. So this is the way that you can be able to push a specific notification to the user. I know many people find it difficult to send event to a specific user, but this is the way that I figured it out, that you can easily push SSE event to a specific user within the application. So after configuring all this, we need to go ahead, and you can see we have post route over here and SSE route, but we have not made use of it in any way. We have not coded anywhere. So after we have done all this, we need to go ahead and call it in our main index.js so that we can be able to pass it as our express SSE. You can see it over here that there is no way that the user can connect to application without those routes. So let's go ahead and import those two routes from route. So we have imported these two files. Now we want to go ahead and pass it as an express middleware. So in order to pass it as an express middleware, we can pass it over here by saying app dot, or we can pass it after this our Mongo. Okay, in order to use this express middleware after our database connection, let's go ahead and call app.use, and then we can pass in this our SSE route like that. And the next one, we want to pass our post route as well. But when somebody is trying to access this our post route, we want to create a virtual key. So /API. Then the next step is to pass our route, so our post route. So you can see these are the middlewares that we have used over here. So when we go up here, you can see these are the two routes that we have imported, the post route and the SSE route. And then we want to use them within our index.js so that users can be able to go ahead and call this endpoint. So this is basically, we are basically done with our server. Now we can save everything and see before we now move to our client application. Alright, so if you save every file and you come back to our CMD over here, you can see there is no error within our application. Everything is up and running. So we are done with everything server configuration. Now we need to head over to our client-side application, our React.js application, and configure our React.js application so that I can point to our route and listen to post, and also point to our live stream and route so that it can be able to receive live stream real-time data from our SSE. So let's do that. If we open our package or Json, you can see that we have Json React boilerplate dependencies. So let's go ahead and install the dependencies. So cd into client, I've opened my CMD and I'm in client directory. So I will npm install. I need an ndb react ui kit. I need Axios. I need a nano ID, and I need a react-toastify. So these are the packages that I need. So go ahead and install these packages in your client directory. It's your React.js application. Hit enter. Let's wait for it to install. So meanwhile, as it is installing, let's go ahead and configure our app. So over here, we create an index.js file. So inside the index.js file, we need to import an Axios. We need to also configure our server sent events so that we can be able to connect it to our server and listen to live stream data for the server. So let's do that now. Alright, so inside our index.js in config directory, we have imported an Axios from Axios. We want to check if our application is running on localhost or is running on a remote server. So we created this simple variable that we return either it is true or false application is running locally. And then we want to configure our server URL that if it is on localhost, it should point to where our server is running. Remember, our server is running on port 5000, but if it's in production, you can go ahead and then provide the domain name that your application will be running on. So here I've provided my remote domain name where I'll be hosting this application. And then I configure Axios. I want to create an instance of an Axios. Remember, I import Axios from Axios, and I want to create an instance of Axios. This is the Axios that we are going to be making our REST API request. So I've said export. I've said export const Axios is equals to Axios.create. Use this create and function on Axios to create an instance of Axios. Then to provide a base URL, I call this server and append it with slash API so that whenever we're making any request to the server, we not need to do forward slash local full HTTP column forward slash this slash API slash post. No, we provide the base URL here, and then we want to enable auth and authentication. This is optional, but remember, if you set on the server when we're configuring our course, we set our course to have credentials true. So on the client too, we must pass this with credentials true so that it can allow cookies and headers if you want to. Then we create a stream URL. This is the stream URL that will be listening on our live and real-time data. So this server URL is the same server that our server will be listening on. So this is the server URL, and then we append this stream over here. So in order to instantiate our server sent event, our server sent event is from event source, and our event source extends event target. So we call new event source, and then we pass the URL we want to connect to with an optional option. Since our server is allowing cookies, we need to pass this option to allow cookies as well. But if your server is not allowing cookies or auth, you can go ahead and remove this option. So we pass the stream URL over here. So if we check our server directory, you can see that this string URL matches the route that we define over here in our SSE route on the server. So remember, we said this we should make request to forward slash https and localhost colon localhost forward slash http colon double forward slash localhost slash stream. So this is a route that will be listening on live data stream, and it's the same thing, the same route that we have specified over here in our stream URL. So this we now, whenever if we run this application now, this and class event source that we have called is going to go ahead and establish an initial connection with our server through this route that we have defined over here. So once it has established connection, whenever we push down an event through this route, a real-time event, our client application will automatically listen on it through this. And we have exported this SSE event, an instance of this event source. So here in our libs, we have imported Axios from config, these configurations that we have just done, and we have created a function known as getPost as an async function. Then from there, we go ahead and make requests, use the Axios to get post. Once we get the data, we return an object with data and error false. And if there is an error, we return a data with object error true. And another thing is another function to create posts. If we want to create posts, we get post that we want to create as a parameter, maybe an object containing keys, and then we send it to this post route, and we return error and data accordingly. Another function that we have created is post reaction. When we want to react to post, when we want to like a post, we call axios.patch. So you see axios.patch, we send it to this slash post, including the post ID and everything inside the body, that is the user that has liked the post, and the post ID will be an object. So that is what libs is all about. Under our actions, we have created some few actions, just get post string, get post reaction. Post reaction. These are just a few actions that we have created instead of hard coding it in our code, we decided to create them as variable and export. So another step here is to create our context. So our context is where our logic in our application lies. So when you come under context index, we have imported React, create context, useReducer, useState, useContext. We have imported all our actions over here, get post, get post string, get post reaction. We have imported in our SSE event that we had configured it in, that we had instantiated it in under the config. So you can see our SSE event here, and it's the one we have imported from we have imported in context. And you can see get post from lib. We have also imported app reducer. When we get to this app reducer, we have imported nano ID and toast for toasting a message or showing a pop-up notification. Then as with context, you must create an initial state. So we created an initial state and whole user at the post is loading is error. Then we, in order to create context, you must call this create context function from React. So we call and we pass our initial state as this one at the top over here, and then we have to create a provider that we can be able to pass the root of our app to make our state globally available in our application. So we pass parameters of probes, and then from useReducer we destructure app state and app dispatch, because for you to be able to make use of to make a request to push to dispatch and an action and payload to the app reducer, you must make use of a function known as dispatch. So and then we pass in app reducer. We will get to this app reducer because as we use reducer hook in React, we must pass the reducer at the initial state. So this is the initial state, and our reducer will be getting to our reducer to see what is inside our reducer. It's just a normal JavaScript function that takes care of interacting with our store for us. So we want when this component is rendered, when it's only rendered or when it is mounted, we should be able to get the post by default. So in order to use this async function, we have to create and get fetch post as an async, call this function, and when it's returned, then we will dispatch. We call this app dispatch so that it can go to app reducer. So we call passing the key of the action type with the key of get post and the payload. Then we immediately call this function here so that it can execute. Then this is where the logic of our SSE event lies. By default, when a message is sent to the server without any custom event, this message is the default event. So we want to listen to it. Since we are not making use of it on the server, I just decided to listen to it here to show you people. So, but on the server we had post event, and we also had some other event. So when post event is pushed down to our client application, normally the parameter you pass over here, the data key is automatically, the data that is being sent from the server is automatically being attached to this data. So we get it, but we don't just want to show notification. If for instance I'm the user that has created this post, I don't want to receive any notification like incoming post because I already know that the post is coming. So I check over here if the current user ID, you can see the user that we have created over here and the structure here from the app state is not equal to the user that has created this. If user ID is not equal to if current user ID is not equal to the user that has created the author of the post, then go ahead and show a toast notification that incoming post. So this is just a front toastify. You can check the library out. This is how you show a notification. Alright, after showing a toast notification, we want to wait for 500 milliseconds before dispatching the post string to the app reducer. So I told you before you communicate with, you can be able to tell the reducer to do anything in the store or to update our global store, you must dispatch with action and the payload as the object keys. So now Another event that we're listening on is on post reaction. When someone likes a post and it comes, so if the liker, that is the liker, which is in this case will be the liker ID, is not equal to the current user ID, then we will say someone reacted to your post. Else we will say new post reaction. So that would be the message, and then we go ahead and toast the message so that we can have a pop-up like message. So you can check out the React Toastify. Another one, then immediately we show the pop-up, we want to notify, send this thing to the store so that we can be able to update post count, the like counter. So we emit or we dispatch an event or an action type of post underscore reaction with the payload. So that is it to the store. So another event I'll be listening on is on notification dash user ID. Remember, this one is going to be specific to any user that joins our application. A user comes over here, the user ID is 1, then the notification will be notification dash 1. If the user ID is 2, so they can never have the same user ID. So this one is specific to a user. So when you want to send a notification that is specific to a user, this is how you do. You attach a key string. You can decide and listen on globally on just the user ID, which is unique. But if you want to attach in order to separate your event types, that is when you're using SSE, you just attach a key to it and add a user specific ID, because user ID can never be the same irrespective of the user that has joined. So if it is a notification that is coming straight for a single user or specific user, we go ahead and toast his notification for here as well. So another one, when our server sent event is open, that is when the initial connection is made with the server, we want to console or log the event. And anytime that there is an error, maybe disconnection from between the server and the browser, we want to also show an error. And whenever our component is on mounting, we want our component to re-render when user ID has changed. So this one, until I don't think the user ID is never going to change. So but this use effect depends on what? This use effect depends on the user ID. So in order to call this context, in order to pass it as a provider, I have to call app context. App context is the one we created and pass initial state. Look at it here. App context, app context dot what provider. And in order for you to pass a value that will be globally accessible in our application, we have to call this value key and then say equals and pass an object. So you can see we are passing the app state, where we can be able to get our state of the application, and app dispatch, which will be able to communicate, a function that will enable us to want to communicate with our store through the reducer. So this is the app state that will structure over here and is the one that we pass as value and as app dispatch. So we use the app state to get the global state of our application, and we use the app dispatch to dispatch action and payload to our reducer in order to make changes or update to our store. So for we to be able to use this producer, we have to pass what pros.children. So the pros.children can be what and React component. So in order to use this app context in our global application, we have to call or use app, create a function known as use app context, and then call use context word hook. So use context hook is imported from React. So after we call it, we will now pass the app context so that we can be able to access these two values, app state and what app dispatch. And then we export this one as a named default and as a named we export this one as a named export, and we export this one as a default export. So in order to make this thing globally in our application, we have to go to index.js and we import app provider from context. So you can see this app provider, look at it here, that we exported as default is the one, so that we can go ahead and wrap our whole React component in order for us to be able to access our state within our application. That is our use context state in our application. So we call this app provider and wrap it the whole of our app. So that is how you do it. So the next step after doing this is let's take a look at how the reducer is looking like. So the reducer is just a pure JavaScript action that takes the state and the action and then returns the updated state. So we call all these actions that we import all these actions that will be dispatching to our store instead of hard coding. Remember, in our context over here, we are dispatching different actions. Over here we dispatch post reaction. So we say whenever they dispatch an action with type. So remember I told you the dispatch function is going to take action of type and what and payload. So whenever the dispatch action are type post, we will destructure the payload and get the data and the error, and then set our post to that data is loading false. Remember, in our initial state over here is loading is true. So by default, so we want to go ahead and make it loading false so that you can go ahead and display our post. Likewise, if they send post string, that is whenever a user adds new post, want to broadcast it, add it to store for all users. So we get the post and then we add it to our post and we spread the previous post in our array. Likewise, post reaction, when it dispatch, we want to look through it, find the post, and then what? Add the post likers. So, and then anytime we do this, we return the state so that it can be updated in our component in our JSX. So you can see anytime we do, we return the state. So this is one thing about global state management. Anytime a value changes over here, all our components where we have used this state will update automatically. So we see everything. So by default, when no action is dispatched, we will return the state. So that is what the reducer is doing. So after we have done all this, the next step is to go ahead and render all these state in our application. So in order to do that, we have created a component. So in this component, we have created three components over here: the post card, add post modal, and post. So let's check post, add post modal. So add post modal is a modal that is responsible for adding post. So it's just we imported React, imported useState since we are going to have an internal state. We imported all these components from NDB React UI kit, so button, modal dialog, and all this. We imported create post from libs so that this function can be able to make requests to our server. We imported use app context so that we can be able to get the user ID and then add it in our post object to know the user that is creating the post. So we created some state over here: the title, image, content, message, and loading. So we created a handlers over here, function handler, so that we can go ahead and touch them on input change. So whenever any of these input changes, this is a control component. So we created all this and we create a function to reset after we have sent the phone to the server. We will reset the variables. We create a function of handling submit. So we say if not title, if they are empty, then it should return an error message that all input are required. Yes, we do try and catch, and we call create post. We pass it an object with title, photo, user ID that created content. So and then over here we set is loading false. So like that, these are the function. Then over here just normal JSS. So we call toggle over here so that when this button of close is created, by the way, this component is going to accept two properties: is open and toggle show. So we pass is open over here so that the modal can show, and we pass toggle here when they want to close the modal. Then we create a form with NDB input. The value is type of input. We pass the change function handlers, pass placeholder, and all this. So likewise image link on this one, and we say if it's loading, should show loading spinner. So this, don't worry if you cannot see this, I'm going to drop the link to this repo in the description of this video so that you can be able to have access to this and see all these things. So the next component over here is we want to display our post. So in order to display our post, we need to call, we imported some component React, we imported some other component from NDB React UI kit. We import use app context so that we can be able to access the values in our context. And we import post reaction function from Ellipse so that we can go to push the reaction to our server. We imported post underscore reaction from actions. So, and then in order to get some values from the global, from the context or global store, we need to, we remember on under this context we had pass and app state and app dispatch. So when you call this use app context, you can be able to access app state and what app dispatch. So over here we have called this app state, and inside app state with the structure to get user ID, we say comma and we get app dispatch so that we can move the dispatch action to the store. So within this, we say whenever someone clicks on the button, we create a function over here to handle post like. Whenever someone clicks on the button, we want to go ahead and then dispatch an action type of post reaction with the post ID and the liker. We increment the liker for that user, and we add this user to the likers ID. So to the likers array, I mean to say, and then we go ahead and send this thing to the server so that the server can process it and send out SSE event to other users. So and then our JSS, we create a NDB card image so that we can be able to show this. We can be able to show the card image of our post over here, and we create card body so that we can show the post title, and we show the post content over here. So and then we want to check to know if this current user within our application, if he has already liked a post, we show the button of read. But if he has not liked a post, we will show him the button so that he can be able to like. So we are checking. Thank God that the likers array will contain all the user IDs that have liked a post. Then we are using include. Include will return true or false if a particular user is included in an array. So this user ID, if it's included in likers, we want to show read that he has liked the post. You can see color will be danger of with icon of heart and no event app. And then we go ahead and show the likers count by calling the post.likers.length. So if it is 1, it will show. If it is 0, it will show. For the meantime, let's leave it 0 to show. So and then else, if the user has not liked this post, we will go ahead and do what and show him a heart so that he can be able to click with a on click listener so that he can be able to what to click this to like the post. And this is the handle post like, that function that we create over here, so it will handle all this logic for us. So you can see over here, this is the postcard. So in order to use this postcard, we need to call it in what, we need to call it in post. So post is the one that we get all our post from what, use app context. So from use app context, at the top over here, we import React, we import some component from NDB React UI kit, we import and use app context from our context, we import postcard, this one that I've just described over here, and then we destructure some properties from app state from our use app context. We check if it is loading, it should show, and if it is error, it should show an error occurred. And again, if post.length is equal to 0, please click on the button at the top. We go ahead and look through it, but to drop it inside NDB raw so that we can be able to have a grid-like system. And then each column we call the key p._id because each post is going to have an underscore ID. And then we call this postcard and pass post as a prop. So the postcard is the one that I just explained. So the postcard is going to take a post property, and then from there it will go ahead and display the post details in our component. So that is all about the component. In order to use this post in our application so that we render the post within our application, we have to call this post in what, app.js. So our app.js. So over here in our app.js, we import React, we import useState, we import the post, this post component, we import add post modal so that we can go ahead and show a button like click here to add post. NDB container, NDB button, toast container, because for you to be able to use this toast, you can you can see over here in our context we're making use of toast from React Toastify. So in order for this toast to show, you must pass a toast container in your main app. So look at the toast container over here. So the toast container, look at it, we call it as a JSS component over here. So you must do this. So and use app context from context. Then for your NDB React UI key to render, you must import this CSS file. Also for our React Toastify to show our pop-up notification, you must import this CSS file. And then we import our normal and app.css. In our app.css, there is nothing much, CSS and selectors, so you can see. Then we created we created a state and a function. We create a state of open and set is open with by default false so that we can be able to open our modal and toggle our modal. So and then we call this function on. We create a button over here and we call this function on it and say add post so that the button at the top, when someone clicks on it, it will toggle the modal and show this post modal for us to be able to add any post. So we say over here, if it is not error, then we tell a user that open this app in a new tab or windows and try to add new post or like a post and see the real time functionality in action. So here, and then we go ahead and call this post component this post, because we need to call this post component in our main app.js in order to render this post that will be visible to the user. So we create a container, import this container from NDB React UI kit over here, see the container, and then we pass in this post. Remember, we import post as well, and see add post modal over here, and we call post and we pass in the word the add post modal and pass in the prop of is open and toggle show. So and is open and toggle show are the properties that add post modal we accept and show or hide the modal. So after doing all this in our app.js, we need to come to public index.html and pass this link tag over here pointing to our font awesome. Whenever we are using font awesome library, we must call this link pointing to the CSS of font awesome library in order to use icons within our application. So once everything is done, let's save everything and go and then test it out. Alright, so the second post. So let's try to like the post and see what will happen. So you can see this user has received a notification that someone has liked the post, and the post has changed the counter accordingly. So likewise, if I scroll down and like this one again, this user will receive this a return notification notifying. So what if I decide to add new post? Alright, so supposing we add a new post, supposing this user adds a new post, we enter the post title like hello world, this is me, and post the image link. By the way, if you want to get any image, you can come over here on unsplash.com, just hover over any image and then copy the image address. Go back over here in our application, you can see we're adding a new post. Let's minimize it so that we can see the post appear, send a notification. Immediately we add the post from this side on the right hand side, it will appear on the left hand side immediately. So that is the real-time functionality. So let's assume we submit the post. So you can see new incoming post and the post appears here immediately. This is the user that has added. So supposing I like my own post that I've just added, this new user too will receive a notification. You can see there is a notification and a counter increment over here in real time. Everything is in real time and it's being sent from the server by server sent in vain. So if I like this side, this user on the right will receive two notifications telling him that his post has been liked and the post liked. So you can see that we are sending notification to a specific user as well as broadcasting it to all users. So if for instance I like this post, you can see he has received two notifications that your post has been liked by user. So you can see everything is in real time. Likewise, if this user too go ahead and add any new post, it will appear in that side in real time. Hi, this is just a test. So, and I'll press the image link and I'll say hello again. So, and if I submit, if you check on the right hand side, the post will appear immediately. That is a broadcast being broadcasted to everybody. So you can see the post over here. You can see it this side as well. So you can see it. And if I go ahead and I like this post, this user will receive two notifications that his post has been liked by this user. And if I like, you can see the counter is incrementing just like Twitter. So this is how you can be able to do. So if we go ahead and open multiple channels, is that all the users will be connected. For instance, now we open another browser tab. So supposing this user like this post, supposing this user likes this post, you can see if you check very well, this one will be incremented, this one will be incremented, and this one too will be incremented. So let's check it out. So you can see 222. So and if I scroll down again, this one is already having six likes. So 6 and 6. So if if I like this one, you can see it has incremented to 7. So you can see over here to is 7, here is 7, and here is 7. And if I like again, it will be incremented 8. So you can see the read time. So supposing this post is like over here you can see these two sides have received notification, and if this user like, these other two sides will receive notification, and if this user like, these other two sides, and you can see the post counter is incremented. And supposing this user now adds a new post like hi, this is new post, and I paste the image link, and I say hello world, then I submit the post. You can see that if you check these two left hand sides, this post is going to reflect immediately. So you can see new incoming post, and the post has reflected immediately. So you can see it here, see it here, see it this side. So now supposing this user like this post, the post will be incremented in all the three. So you can see this and these two user has received two notifications telling him that his post has been liked, and the general notification as well. So this is how Twitter behaves, and this is the technology behind Twitter. So this is what they use behind the scene. So you have learned how to implement this. You can see whenever I like the post, and if I like, it has gone to tree. You can see everything is in real time. So I guess you have learned something new today. So the next thing that we need to do now is to take this client application and the server side application and host it. So but in this tutorial we'll be hosting it on cpanel, but you can go ahead and host it on any server, be it Heroku, be it any server, and everything will still work. So back here in our VS Code, in order to host our project, we need to make some certain configurations. First of all, in our client directory, we need to go to public directory and create a file known as .htaccess, and drop this configuration inside. So you can see the configuration I've made over here. And if you want to get this configuration, I've already made it in one of my video, and I've dropped the link for downloading this configuration. So the link is up here. Just take the video that is displaying up here and then watch it, and within the description you can be able to download this configuration so that you can add in your react.js application. So after you have created .htaccess and added this configuration under public directory in client, the next step is to open package.json. So when you open package.json, we need to point this package.json to the URL that will be hosting this application. So in this case, in order to do that, we need to add a new key known as home page. So homepage, then we give it the value of the URL that will be hosting this application. So in this case, the URL I'll be hosting is sse.tech45.com. So HTTPS, just write the full URL, will save everything. So if I go to my client, to my libs, my config over here, you can see that I already configured it to point to my server. So if you have not done that, if you are connecting locally, come over here too as well. You can see I said if it is a first of all created a variable, and then I said over here that if it is on localhost, it should make request to where my localhost server is hosted with. If it is online, I mean it is hosted remotely, it should make request to this. So this https colon double forward slash api.ss.tech45.com is the domain name that I'll be hosting my server side. So you can see we need to consider what the server side. So when if you use this access to make requests, ensure you change this as well, or else you'll be receiving error in your application. This one is pointing to, this one is a client application. So you can see it doesn't have that API, but we need to also host our API somewhere. So and remember our client application is making request to our API. So you can see I have a subdomain here known as api.ssh. This is where my server will be hosted, and this the one in package.json on the client side will be pointing to where our client application will be hosted. You can see the two domains are different. So after you have done this, the next step is to go to cmd and build. So after the server has been stopped, go ahead and run npm run build, and we'll wait for it to finish building. Alright, you can see our project has finished building. So the next step now is to navigate to the directory of your project. So here I'm here in my directory, and go inside client. So when you go inside client, you will see the build directory if your project is successfully built. So inside the build directory, and add to archive. By the way, if you don't have WinRAR, go ahead and install it on your Windows if you're on Windows. So add to archive, cpanel. So select the option of zip and click on OK. So we have zipped all the build folder in our client directory. Go back and then go inside server. So but on that server now, let's change the view so that you can be able to see. Let's take it to large. Deselect node modules and deselect package or JSON, and then zip the rest of the files. So you go to add to archive, and we add to zip. So you can see our server 2 has zipped. So if you did not select node module, so you can see the whole of my file over here is just 5.11 KB. Do not select node modules and do not select packet or JSON dialog. So after we have done this, we go ahead and log into our cpanel. So if you have cpanel account, the one that I'm using over here is shared hosting account on Namecheap. If you have cpanel account, go ahead and log into your cpanel. So I've already created two subdomains that I'll be hosting this my application. So within cpanel over here, we have different sections. We have the email, we have the exclusive for Namecheap, we have the files, we have the database, we have the domains. So if I go under subdomains, you can see I've created two subdomains, one API dot SSE dot tech45.com, and I've created another one SSE dot tech45.com. So you can see API.sse, this is a one that will be hosting our API, and I've also created an SSE. So and I created SSE. So these are the two subdomains that I've created. By the way, if you're not created or you already have your own subdomain, you don't need to bother about this. So if you ensure that you have two domains ready to host your application, now come back to this cpanel page and go to files manager, to file manager, to files file manager. So once you come over here in this files manager, if you created a subdomain, a directory will be created by the name of that domain automatically for you. So we want to host our client application in sse.tech45. So you can see the domain, the subdomain a directory is already created for us. So after you have deleted, click this button known as upload so that you can be able to upload your project. So once it takes you here, check this overwrite existing files, check that option and then click on select file. So once this file explorer is open, go ahead and navigate to that directory where your project is residing. If it's within desktop, you can check within desktop and where your project is. So just go ahead and navigate to that directory. So over here, so I'm a client, and inside client, remember we entered inside build, and inside build we this is where we built our project. So select the build file and wait for it to upload. So after it has uploaded, click on this link to go back to File Explorer and select the zip file and click on extract at the top. So and click on extract files. So it has extracted. So if we go ahead and try to test out our application by typing SSE.take45.com, the domain name, we should be able to see our application, but it should return error because our API is not yet hosted. So you can see error has returned. So the next step over here now is to host our client, to host our API. So even our API, since we created a subdomain, it has automatically created a directory for us. So look at the directory over here. So you enter inside. So there are files, the old version that are hosted. What I will do is I will select everything and delete. I don't need it. So delete. So after you have deleted, go back to this and main menu, this and our cpanel main menu, and scroll down to software section. Then you will see setup Node.js application. So click on setup Node.js application. Alright, so it will take you to this page. So once you come to this page, click on this button known as create application. So now, first of all, change the version. So the version I use over here, the development is version 14, Node.js version 14, and change the application mode from development to production. And next is asking you the application root. So the application root is the directory over here, this API. So go ahead and enter the directory of your where you want to host the Node.js application. So, but over here, I'm going to host it in this domain, this directory that was created for my domain. So it's api.ss.take45.com. So I'll go ahead and type the domain name over here, api.sse.take45.com. By the way, if you enter a directory that does not exist, it will automatically create it for you. So, but since we already have this one, it will go ahead and configure the directory for us. The next one is to choose the application URL. So where is the application URL that we're hosting this? We'll be hosting it on api.sse.take45.com. That is the domain. The next one is asking us what is the application startup file. So when we are developing it under our development, our startup file was index.js. So we'll go ahead and enter index.js and you click on create. So once it has created, you will see the success message. Now if you want to test whether the application is working, go ahead and click on this open button. So you can see it says it has worked. So if we go back to our file manager over here and refresh the directory, for instance, we just click on it to refresh again, you see the index.js we asked it to create, and it has configured the htaccess for us. So after you have done this, come back over here in this under this Node.js application again and stop the app for the meantime. Stop the app. After you stop the app, go back to file manager. We want to upload our server files. So click on upload. Now come out of this client directory or locate your server directory. This is the server, and select the build package, the build file. This server, the build is the one. Select it And after it has loaded, just navigate back and select the zip file server.zip and click on extract and extract files. So after you have extracted the files, go back to your Node.js application over here. We want to be able, you can see we uploaded the files together with package.json. We want to install the dependencies on our remote server. So what you do is refresh the page. So now scroll down to the bottom of the page and you will see this button of run npm install will be activated. So after that, click on install. So you can see it has installed successfully. So the next step is to go back to this file manager and select the zip file and the package.json file. Select the two, the zip file and the package.json file by holding your control. So and delete the two files. So after you have deleted, go back over here on our Node.js app and refresh the page. You can see that the button is activated because our package.json is there. So we remove the package.json so that this button will be deactivated. We don't want the package.json to be there so that if a third party has access to that, it will be able to know the dependencies that we have used. We don't want that. So if you scroll down, you see the button here is deactivated now. So just go ahead and after it has been deactivated, go ahead and start the app. So if you want to test whether our app is opening again, let's go ahead and open it again using that open button. So you can see api.sse.tech45 is the subdomain we have hosted our server. So we want to see if our server is up and running. So now it shows that our server is up and running. Let's go ahead and refresh our client application. So you can see error is returned because there is no post found in our database. So let's go ahead and try to add new post. So in order to add new post, let's head over to unsplash.com. You can see unsplash.com and copy any of these image links. So let's just copy this one, copy the image address and go back to our application again and click on add post. Then add the post title hello world, add paste the image link and add the content hello, this is a test a remote, so and click on submit. So you can see success over here. It means that our post has been added. So you can see that our post has been added successfully, so we can go ahead and like and unlike. So let's add more posts. Supposing we scroll down here and we try to like this post, you can see this user has received a notification. It's likewise if we like. So our real-time functionality is working even on the remote server. What if we add a new post? So let's go ahead and add a new post. Hi, this is you. The next paste an image link and the post content. This is great. So and then submit. So you can see new post added successfully and the post has reflected. So if we should go ahead, someone should like this post. You can see this user has received two notifications, one specific for him that his post has been liked and the other one that the post has been liked. So if I like over here, you can see the counter will increment as well. So we have come to the conclusion of today's tutorial and I hope you have learned new things today. So please just do me a favor, go ahead, like, subscribe to my YouTube channel and share this video with your friends. You can see we have built a cool looking and real-time application over here. Whenever we do anything, the other users will receive it in real time, and we have solved about two problems over here: broadcasting to all the users and broadcasting to a specific user. And we can be able to add new posts, we can be able to like a post, and everything is happening in real time. please and please just like and subscribe to my YouTube channel for more awesome videos like this. Thank you. See you in the next video.